So today we're looking at some graphs, still exponents, right? I filled out this part here. It's not filled out on yours, so you can fill it out. These are the parts of the exponential equations or functions that we're going to be looking at. Okay. So exponential functions, how do we know it's exponential? When the variable is up in the sky. When the variable is up in the sky, it's an exponential. It's easy to tell if you're dealing with an exponential equation or exponential function. The exponent, x or y, are up in the sky. Usually it's x. If it's up in the sky, it's exponential. Okay. And then it's got two parts, a and b. A is what we call the starting value. So when x is 0, that's what y is. It's the starting value. When x is 0, y is whatever a is. Okay? Also known as the y-intercept. It's also the y-intercept as well. Okay? B is either called the multiplier or sometimes it's called the growth or decay rate. How fast is something growing? How fast is something slowing? That's what we call B. Okay? It's the growth. If it's growing, if it's getting bigger, it's a growth rate. If it's getting smaller, it's decay. Okay? Things are either getting bigger or they're getting smaller. Anything. Okay? If they're staying the same, the growth rate or decay rate, it's just constant. It's 1. Okay? So if it's staying the same, this is 1. If it's bigger than 1, it's growing. If it's smaller than 1, it's dying or decaying. Okay? If it's not growing, it's just 1. Okay. Okay, so when do we know if it's decay or growth? Decay or growth? Well, if it's growing, if B is the guy we look at. A doesn't matter. B is the guy we look at. If B is bigger than 1, if B is a bigger number than 1, it could be 1.1. That's bigger than 1. It could be a million. That's bigger than 1. Anything bigger than 1, if B is, it's going to be considered growth. What does growth look like? Growth, when we graph it, it'll always look something like this. It'll always look something like that. I drew one on the board too, the purple one on the board. Now, it can move up or down, left or right, but it's always going to have this kind of curve to it. It'll always have that kind of curve. Something like that. Where the right arrow is going up in the sky. The left arrow is going to the left. Okay. When is it decay? Well, it's decay if B is in between 0 and 1. If B is in between 0 and 1, it's going to be decay. So when I say between 0 and 1, what type of numbers are between 0 and 1? What's an example of a number between 0 and 1? 1/2, right? 1/4, 0.25, right? Those are the numbers that are between 0 and 1, okay? Those graphs will look like this. Same type of curve, just kind of opposite direction. Opposite direction, right? Again, it could be down here, up here, over here, but it'll have that same shape. So when you look at an equation, we're going to look at 6 of them right now. In your head, you should be able to tell, okay, that guy's going to look like that. Okay? You'll have a kind of a look at it. Okay. Asymptote, we'll deal with asymptote later. Don't worry about asymptote. We'll talk about it on the next page. What I want you to do here is identify B. First thing is identify B, and then tell me if it's growth or decay. So how do we identify b? Well, go back up. What is b attached to? B is always going to be attached to the x, right? The x in the sky. It's always going to be attached to the x in the sky. That's how you tell what B is. So let's go down here. Number 1, what value is attached to the x? Which value is attached to the x? 2. That's B. So based on that, is it going to be growth or is it going to be decay? Yeah, it's bigger than 1. So if I were to graph it, the graph would look something like that. It's growth. It's growing. This function is growing. Growth. Okay. Number 2. Which value is B? Which one is attached to the variable in the sky, to the x in the sky? This guy right there, right? That guy right there is attached to the x, right? So 3/4, is that bigger than 1 or in between 0 and 1? Between. So that means this guy is decay. All right, so I want you to do that for the rest. Do that for 3, 4, 5, and 6. What is B? And then tell me if it's growth or decay. Okay, so I highlighted the B's. Those are the B values. 3/2 is 1.5. It's bigger than 1. So not necessarily a fraction. So some people say, if it's a fraction, that means it's lower than 1. No, there's a lot of fractions that are bigger than 1. Number 4, the fraction for number 4 is smaller than 1, though. Number 5, smaller than 1. Number 6, it's 5 whole. That's growth. Growth. Okay? All right, so now let's go to the back. The back, we're actually going to be graphing some. Okay? The hardest part about today is using your calculator. That was the issue with the last class. So you're going to need a calculator. Your phone's okay. Today we're just doing notes, so you can use your phone. So get your phone ready because we're going to be doing some calculations. Okay? Get your phone handy. Because we need to create an X and a Y table. To do that, we need to plug in numbers, right? All right, so number 7. So we have to graph each of these guys by filling out the table and then answering the questions at the bottom. Okay? So for the first one, we're plugging in a -2 for X. All right, well, X is up here. So I'm going to plug in -2 for X. Now we just took a quiz on this. So what is the answer going to be? What is 2 to the -2 going to be? We just took a quiz on it where you had stuff way harder than this. So yeah, it's going to be a fraction, right? Because the negative means we have to move it to the bottom, right? The negative exponent means move it to the bottom. So it's going to be 1/2 squared, which is 1/4, which is 1/4. 0.25, good. Not -4. I get that a lot. Not -4. We know that negative power doesn't mean make it a negative. Next one, -1. -1 power means move it to the bottom. Two to the first power is just 2, so 1/2, which is the same thing as half. Okay. I'm going to highlight my dots because these are all dots that I'm going to make on the graph in a second. 0, plug in 0. When I plug in 0, I get 2 to the 0. Anything to the 0 power is just 1. 2 to the first power. Anything to the first power just stays like it was. And then the last one is squared. Two squared is 4. So now I have 5 dots. 5 x's and 5 y's. So I'm going to go make dots below. So the first dot is at negative 2.25. So that means I'm going to go left 2, up a quarter. So I go left 2. I can't even go up 1 a full. I can't even go up a full unit because it's a quarter of a unit. So it's barely above the x-axis. It's right there. The next one is negative 1.5. Negative 1 up half a unit. Next one is 0, 1. Okay, next one is 1, 2. Next one is 2, 4. Okay. And then you're going to connect the dots as best you can. It's not going to be a straight line. It's going to be a curve. We talked about it. It's going to be a curve. All of our graphs today will be curves. They're not going to be straight lines. Okay. That's what the graph looks like. It's growth. We knew that before because b was 2, bigger than 1. Okay. All right, so now we got to go answer the questions in the back. So now we got to answer the question on the back, on the bottom. So first of all, is this an example of growth or decay? Growth, yeah. It's growth. Asymptote. Asymptote is another word for the bottom of the graph. Okay? So if I had a line here, let me draw a line here. Draw a blue line. And I wanted to move this blue line to whatever the bottom of the graph was. Bottom means everything's above it. Would the graph be up here? Would the line be up there? No, that's not the bottom. How about down here? That's too far down, right? Where would it be? There's the bottom? No. Closer, right? Closer. Too far. I think that would be the best place for a bottom, right? So the bottom is the x-axis, right? Another name for the x-axis is everywhere y equals 0. Everywhere y equals 0. Okay? Everywhere y equals 0, that is the x-axis. Another word for the x-axis is x equals 0. Or sorry, y-axis is x equals 0. Okay, so that's the bottom. So asymptote is another word for the bottom. Where is the bottom of the graph? Because these guys are going to have bottoms. They're not going to have tops. I can't possibly put a top on this guy because this arrow would break through it. Okay. Okay, so next one, y-intercept. Where does it cross? Where does it cross the y-axis? Where does it cross? What dot is it cross the y-axis? Right there. That dot right there. That dot is at 0, 1. Domain and range. Domain and range. Okay, so domain and range. erase this line first. Domain and range. The domain focuses on this line right here. The x-axis. So we're going to look at this graph only through this. The y doesn't exist. I know it's hard to take away, but we're trying to take away this guy. I just want to look at this. I'm going to take the arrows, left and right. All I worried about is left and right. So I'm going to go to the arrows. First arrow is here. Oops. First arrow is here, right? Is that guy going to go left? How far is that guy going to go left? Forever, right? Which direction, the positive or the negative direction? So we would say that it's going to go to negative infinity. Okay, so that's where we're going to write down. We're going to say negative infinity is where it's going to. And this is where it gets a little confusing. This arrow here, it's going up. I know that. But I don't care about up right now. I just care about right and left. So is this arrow going right or is it going left? It's going right slightly, right? It's going mainly up, but it is going to the right as well. Will it ever stop going up and right? No. So because of that, we say positive infinity. It's never going to stop going to the right. The domain is left and right. The range is the opposite. The range is top and bottom. Okay. So now we're not thinking left and right anymore. We're thinking top and bottom. Okay, so let's start with the top. This, is it going to go up or down? Up, forever and ever and ever, right? So the top is what? Positive infinity because it's going up, right? Positive infinity because it's going up. Good. The other arrow, this arrow right here. I know it's going to the left, but we're not doing left anymore. We're doing up and down. So this arrow, is it going down or up? Down, right? It starts up here and then goes down. It kind of slows down, right? Here it's going down really fast, but then here it kind of slows down, right? But it's going down. How far does it go down? Here's where I'll tell you. The answer, how far it goes down, is always the same as the bottom. Didn't we say the bottom? 0. So that's where the bottom is at. We already said that's the bottom. So domain is right and left. Range is bottom, top. Okay. All right, let's look at the next one. We got a fraction now, 1/3. 1/3, plug in the values. Okay. So 1/3 to the -2 power. What does that mean, -2 power? What do I got to do to that? How do I, again, we did this. We've been doing this. We did it on the quiz. We've been doing it for the last couple weeks, right? What is the -2 power going to tell me to do? What do I got to do first? Before I start doing up and down, right? Before I start doing up and down. Which rule do we do first? Right, I have that, right? But it's a fraction as well. So it looks like a 7, right? It looks like 7. Give the top a fraction, give the top a power, give the bottom a power, right? That's what we do first before we move things up and down. Give the top a power, give the bottom a power. Now we can move up and down, right? Now we move up and down. Now the 3 squared moves up and the 1 squared moves down, right? So we get 9 over 1, which is the same thing as positive 9. That's our first dot. Our first dot is at negative 2 left, up 9. Next one, plug in negative 1. Give the top a power, give the bottom a power. And they switch spots, and I just get 3. Next dot, negative 1, 3. Next thing, plug in 0. Anything to the 0 power, fraction, decimal, positive, negative, it doesn't matter what it is. Anything to the 0 power is always 1. So the next dot is at 0, 1. Okay. Next thing, plug in 1. Anything to the first power stays the same. Anything to the first power stays the same. 1/3. Usually we'd leave it as a 1/3, but if you're graphing it, you might want to change it to a decimal. You don't have to, but if you change it to a decimal, it's 0.33333333 forever and ever and ever. Plug in 2. Which is 1/9, which is the same thing as 0.111111 forever and ever and ever. Okay, so we got to go make dots now. Or the dots that I haven't made yet. Okay. Connect the dots. Yep. Oops. All right. Now we got to answer those questions about it. Is it growth or decay? It's decay. Where's the bottom going to be? Is the bottom going to be in the same spot as the last one, or is the bottom going to be in a different spot? Is the blue line going to be here at the last one? It was here, y equals 0. Is that a good spot, or do I need to move it down or up? It's a good spot. Yeah, looks like it works. Y equals 0. Y-intercept, where does it cross the y-axis? This dot right there. 0, 1. Okay. Domain. Domain is left to right. So let me draw my line again. Left to right. Left to right. Let's start with the left. Actually, start with the right. The right's easier. This guy, is it going to be moving to the right forever and ever and ever? Yes. So we say positive infinity for that dot, or for that arrow. This arrow, I know it's moving up. I know it's moving up, but I'm only looking at left and right. So which one is it going, left or right? That arrow there. Left, right? Slightly, but it is going left. Will it continue in that direction forever and ever and ever? Yes, it will. I'll give you a hint. Exponentials will always have the same domain. Exponentials will always have the same domain. Range changes because they have different bottoms, but exponentials will always have the same domain. All right, so now let's move to left and right. Or sorry, up and down. This dot right here, this arrow, is it moving up or down? And is it going to move that way? Is it ever going to change? No. So that guy right there, so up, positive infinity, right? Top is positive infinity, doesn't have a top. That's what it means, doesn't have a top. Other arrow. I know this guy is moving to the right. I know he's moving to the right. But is he also moving up or down? Down, right? Where's the bottom going to be? Yeah, we already said that, right? 0. It's going to be right there. So the bottom is going to be 0. Okay. Domain and range. Domain will always be the same, right? So I'm not going to focus on domain. Range. This guy is the top. This guy is the bottom. Okay. And this guy, notice those two. Okay. Okay, so let's do the next table. The next table to the number 9. First thing we got to do is fill out the table. Okay. So I'm going to plug in an x. This time I'm plugging in -2, but then I also have to subtract 2 when I'm done. Okay. So what is 3 to the -2? What does that mean when I say 3 to the -2? Move it down, right? Your calculator also does this too. 3 to the -2. It'll do it. It won't change it to it. Oh, yeah, well, 1/9. Okay. It won't do that for letters. Like if you it wouldn't have helped you last chapter because last chapter we had like x -2. It won't do that, but it will help you number. So 1/9. So 1/9. So I have 1/9 minus 2 whole. 1/9 minus 2 whole. That's why you have your calculators out. Go to your calculator. 1 divided by 9 minus 2 whole. There's your answer. -1.89. We'll round up. -1.89. Okay, the next one, -1 power. -1 power. 3 to the -1 power. means move 3 to the bottom. When I move it to the bottom, it becomes 1/3. Three to the -1. Oops, nope, didn't do it. 3 to the -1 power becomes 1/3. 1/3 minus 2 whole. -1.67. -1.67. Okay, next one. 3 to the 0 power minus 2. Well, 3 to the 0 power is just 1. So 1 minus 2 is -1. Three to the first power is just 3 minus 2, which is +1. 3 to the second power minus 2. 3 to the second power is 9. Minus 2 is 7. There are my dots. So let's go make some dots. Left 2 up. So left 2 down this many. So I'm going to go left 2 and then down not even 2. Almost 2. I'm going to go left 2, 1, 2, and then down not even 2. Almost 2. 2 whole. So it's going to be right about there. Same thing for the next one. Left 1, down almost 2. Zero, -1. 1, 1. 2, 7. 3, 4, 5, 6, 7. Well, you know what shape it's going to have. It's either going to have a growth or decay. There we go. Okay, so this one's growth. The bottom. It's been 0 before, but that's too high. I think we're going to need to move it a few units. Looks like -2. Okay. All right. Y-intercept, it crosses at 0, -1. Domain is always the same. Domain is always the same. -infinity to +infinity. The range, bottom to top. We said the bottom was at -2. And the top doesn't have a top because that guy's going up and up and up and up and up forever and ever and ever. So we say +infinity. Okay. All right. Number 10. See, we're probably just going to get to number 10. Probably number 11 we'll do tomorrow. We probably won't have time to do number 11. That's fine. It's all the same type of stuff. The hard part here is just using your calculator, because once you have the dots, once you can see the picture, then it's pretty easy to say if it's growth or decay. Where is the bottom? Where does it cross this line here? Domain is always the same. Range, you guys know how to do that. So the hardest part is graphing, but you have a calculator, so you can do that. Okay? So number 10. I need to plug in -2. So I got to plug in -2. -1. 0. +1. +2. Okay. Well, since you can use the calculator for this, 2/3. So first thing we got to do is parentheses, right? The calculator will do this. If you go 2/3 to the -2, for your calculator, how do I say this? The standard calculator that either iPhone or Android gives you isn't the best, because it's just an afterthought. When they create a phone, they don't create a phone for a calculator. They just throw a calculator on there. So it's never the best, but there are some apps which work great. One of them is this one I'm using right now, which is Desmos Scientific Calculator. It's free. It looks like that right there. Kind of looks like the Delta Math thing you guys have. If you're using your phone, I would use something other than your iPhone or Android, the default app, because like I said, those are great for adding, subtracting, multiplying, and dividing. But if you want to do powers like we're doing now, it's not the best. It does it, but it's a little clunky. So the one I have is Desmos Scientific Calculator. It's free. And it looks like your Delta Math calculator. So you've seen it before. Okay. Or you can just go to Desmos Scientific Calculator. If you go to desmos.com/scientific on your on Safari or Chrome, you can do that too. So you don't necessarily need the app. Okay. The reason I say that is because I'm going to do this one right now. I'm going to do this guy right here. And literally, I can plug in that exact thing and it will give me an answer. Watch. 4 parentheses, what was it? 2/3. 2 divided by 3 parentheses. Nope. Power -2. Boom. Gives you an answer. It changed it to a decimal and multiplied it all in one. The answer is 9. So it's kind of like your Delta Math calculator would do. Yeah, we got 3 minutes left. Let's say -1 now. Let me change to -1. My answer is +6. So if you want to pack up, start writing down. Let's finish the table. 0 power. Anything to the 0 power is 1. So 4 times 1 is 4. Okay. First power, 4 to the first power. Change that to 1. 2.67. Change it to 2. $1.78. $1.78. No, we actually today we have 7 minutes. We got 7 minutes. Let's graph those. -2.9. -1.6. 1, 2, 3, 4, 5, 6. 0.4. 1, 2, almost 3. 2, almost 2. Oops. Okay. Last thing, fill out those. We'll do number 11 tomorrow. The last thing, fill out the growth, decay, asymptote, y-intercept, domain range. Fill those out based on this graph, and then we'll do number 11 first thing tomorrow.